Good morning, everyone. My name is Varun, and I am your CCNA trainer. And welcome to Logic Labs Technologies. Before starting all, am I audible to you? If yes, please reply yes in the chat box. Thank you, Vera. Thank you, Johnson. Thank you, Samuel. Thank you, Victor. Thank you, Manoj. Okay, so this is the day two of CCNA training, and I would like to introduce myself again before starting the session. As I said you, my name is Varun and I hold 10 plus years of IT experience, work with multiple companies on multiple domains, and I hold 6 plus years of online trainer and corporate training. Okay, so this is a quick intro about me, and if anyone wants to speak to me about the sessions or about the course, you can raise your hand and I will provide you the access to speak. You'll have an option in Zoom to raise your hand. Yes. Okay, Johnson, I'd like to give access to you. Hello, Johnson.
Hi, good evening, everyone. So I have a quick question. Is this like for beginners or people with a medium or let's say high level? Because I'm a beginner when it comes to networking.
Okay. All right, let me tell you. CCNA is all about learning from basics. So it teaches you basics of computer networking. This is your first stage of networking.
All right, thank you, sir.
Yeah. Okay. Any other questions from anyone? Okay, Veera, would you like to speak? Yes. Veera, I am providing you access to speak. You can have a talk with me. Yeah, Veera, you can unmute yourself and you can speak to.
Yeah, can you hear me?
Yes.
Yeah, currently I'm working as a system administration.
Okay.
So I'm working as like a Office 365 admin. So how it is easy for me? Like after CCNA, need to do the CCNP or CCI.
Okay. Initially, I recommend you to go with CCNA, and if you find an opportunity as a network administrator, then once you enter into the job role, so you might see many more things. It is not in a stage. It is not something like a college thing, like completing SSC, then PSU, PUC, and then graduation. It is not in that way. So first level is CCNA. After entering there, you might see multiple options for your upgradations. Okay, even if you're going for CCNP, there are two or three modules inside CCNP now. Okay, so based on your requirement, based on your company requirement, and based on your experience inside the company, definitely you have to choose a right option for your upgrade. Okay,
Okay.
got the point.
Yes, yes, got it.
Okay, Veera. Okay, any other questions, Veera?
No, that's fine.
Okay, and it is very much pretty much useful for you because you already hold 3 plus of experience and you might have already experienced networks within your office. So obviously it is going to help you to upgrade your skills. All right, thank you. And any other wants to speak? Any others? Any questions? Any others? Okay, any questions from anyone? Okay, if everyone are okay, then we are good to go and we'll start today's session. Okay, as I informed today, we are going to understand about a new concept. So before that, I would like to provide you the details of our WhatsApp group. As I told you in the earlier, or if someone are attending for very first time today. We'll see about this. Okay, this is a certification level course, and these are the details. And here is a quick link for WhatsApp. You can click on this WhatsApp link and you can join to the WhatsApp group where all the information will be posted. Okay, information related to your course, information related to any sort of practicals, especially network diagrams, or any sort of interview skills questions, or any sort of new updates, placement updates, or any software updates will be provided in this particular chat group. Okay, if you can join here for all these updates. Okay, not just this, we also have a website, Telegram group, Facebook page, YouTube page, Instagram page. You can join in all these things so that you'll get connected to our Logic Labs technologies. Everything is only to provide information to you so you can get more information whenever, if you're looking for a job, if you're looking for some subject, or if you're looking for some skills, it is going to be helpful. Okay, all right. So now we'll see a quick review of yesterday's session. Will not take much time. We'll see a very quick review. So yesterday's session, we have seen something about CCNA, so Cisco Certified Network Associate. So this particular certification level course is designed for a process called learning basics of networking and how to configure a small network with Cisco routers and switches and other Cisco devices, and how to protect your routers with security setups like VPNs and basic network management and monitoring. So all these 4 points are covered in this particular course, and this is a very entry level course of networking. Okay, so where you'll be dealing with all networking devices, but this is the very entry level. Why it is entry level? Because you're going to deal only with this small network. It means within your office or within your organization. Okay. And so yesterday we have taken some basic examples like networking, IP address, network devices, topology, and some definition of router. Okay. All right. So what we are going to learn today. Our today's agenda or today's objectives are, we are going to understand about what is IP and what is IP address. And also we'll see about how to write IP address and how it works. Okay, and what are the classes of IP or introduction of classes of IP along with introduction to subnet mask. Okay, so let us quickly jump on to today's subject. Okay, so in today's session, we are going to learn about IP address. But before understanding that, I would like to annotate it to you in a simple way. Okay, let us consider two people. So I'm taking a small example here. So let us consider two people. So there are two persons, and I want these two persons to talk to each other. How would they talk to each other? Okay, so basically, if two people wants to talk to each other, there should be some service in between them. It means even if they are meeting face to face, if they wants to talk to each other, they should understand what they speak. Okay, so both are strangers and they want to speak to each other. To speak to each other, they require some language. Even if it is the very first time, even if they wants to say hi, they have to wave their hand. That is sign language. That is sign language. Or if they are speaking directly, hi, hello, or they are introducing themselves to each other. So it might be a language, it might be English, or it might be some other language. But yes, for communication, we require a language. Okay, so if two people wants to speak to each other, then we require a language. So for establishing a communication, creating a communication, they require a language. Okay, not just language. After saying hi, hello, then they will start introducing about themselves. Something like, hi, my name is Varun. And the opposite person, yes, hi, my name is Sunil. So they will introduce themselves with their identities. They'll introduce themselves with identities. So here it is a name. So I am writing it as name one, and here it is name two. So now this will create this setup. If they are speaking to each other comfortably and they are introducing themselves, after this, what happens is there will be a conversation which is referred as, this procedure is referred as good communication. Right? This procedure is referred as good communication. Okay. All right. And to start this communication, firstly, what we require, this is the mandatory thing. There will be a, or else let me simply call it as good communication can be referred as a word called as protocol. Okay. So protocol is nothing but a set of rules for a good communication. We are into networking point. So in terms of networking, we will say something about protocol. That is, protocol is nothing but a set of rules with set of rules for good communication. Okay. Now I have taken this example. Similarly, if two computers wants to speak to each other, so how it is going to be? If two computers, so let's say I have two computers with me. So if two computers wants to talk to each other, basically computers don't talk, but they interchange the information which we are calling it as talking. So if two computers wants to communicate with each other, okay, I want these two computers to communicate with each other. So what do we require here? Basically, I'll mention these are computers. So I'll write it as PC1 and this would be my PC2. So if these two computers wants to communicate with each other, then how they'll communicate? Okay, right. So basically, in the above example we have seen, if two persons wants to speak, they require a language. Similarly, to communicate or to create a communication between two PCs, here also we require same thing. We require identity for the PCs and we require a language. Okay, so which creates a good communication. Okay, so here the language is referred as IP. Okay, and the name is referred as IP address 1. And here it is IP address 2. IP address 1 and IP address 2. So here is how a communication started between two PCs. Similarly, a good communication starts with this particular following some rules. So it is nothing but a protocol. So here also they have started using some protocol. So IP refers to Internet Protocol. Okay. And here starts our today's session, which is nothing but IP addressing. So this is our today's concept, IP addressing. And in this concept, we are going to understand about firstly Internet Protocol. Okay. So let's understand about what is IP. Internet protocol. So according to the given example, so internet protocol is nothing but a language between two two computers or two or more computers. Okay, or the reason or the source for this communication. So I am writing in a small understanding way. Internet protocol. So it is a basic communication service. And here I'm adding some more advanced point, which starts with port number 0. IP is a basic communication service that starts with port number 0. Okay. All right. You might ask me, what is this port? Okay. So when communication started, there are multiple services or multiple ways of communications. Okay. So there are multiple ways of communications. For each way, they have designed one particular service. Okay. Among all those services, the very first primary service is IP. That's why it has given a number called as 0. You might ask me, how many ports are there? How many port numbers are there? So there are totally 0 to 65,535 ports. So these many ports are available. It means these many services are possible. Okay. So, but in reality, we don't use all these services. We might hardly use somewhere around 20 to 30 maximum services. Okay. Right. Some of the services like you might experience something like HTTP is a service. Whenever you open your web browser, you will experience HTTP. So it is also a service. It has also got a port number, and HTTP works on port number 80. So I have given an example for this port. Okay. All right. So, and we will explore more about port and port numbers in the upcoming class. All right. Next, the definition of IP address. So what is an IP address? So IP address is a name we have provided to a PC, which will act as its identity throughout the network. Something like if we don't have a name, if we don't have a name, see, our name is given by our parents. Our name is provided or given by our parents. Okay, but basically our human body doesn't have any name. The name is only on your papers. So nowhere our name is printed until and unless you tattooed it. Okay, but basically our name is not printed anywhere. So it is only on paper. So I can call it is something like it is a logical name. And yes, we have sometimes we will get some different names as well. Just assume like you have your name, original name provided by your parents. At the same time, your friends might call you with some other name. And your uh, grandparents might call you with some short names, some nicknames. So it means we have a human have a multiple names which are logical. Similarly, for every computer, we can provide a name. We are providing a name. So that name is particularly referred as a logical name, which is IP address. Okay. All right. So this IP address is always a logical name. So IP address, let us take the definition here. IP address. It is a 32-bit or 128-bit logical address assigned to a PC. As of now, I'm writing only PC, but it can be assigned for other network devices. Assigned to a PC to identify the network. Okay. All right. So this is the basic definition. You might ask me, what is this 32-bit and what is this 128-bit? 32-bit is referred as IPv4 and 128-bit is referred as IPv6. You might still say, Varun, we are a bit confused. So you are telling 32 bits and 128 bits. Basically, what is this? Okay, very simple thing. So for humans, we have names. The names, it means we'll use some alphabets between A to Z and our name is formed. Similarly, for computers, we cannot go with names. If you're going with names, definitely there will be conflicts because name can be repeated. So that's the only reason IP address or the identity for PCs is given in terms of numbers. Okay, and these are the numbers which are very easily understandable by the PC. So that's why they have designed this IP address in binary language. So IP address is designed in binary language. So binary bits are used to provide IP address. Now that IP address, you understood that IP address is provided or it is designed using binary bits. You might ask me who implemented or who designed this IP address. Okay, here we have to see this point. So IP address is, let me say design, is designed by an organization called IANA. IANA refers to Internet Assigned Numbers Authority. So this is the organization who implemented or who designed the IP address. And they have done multiple things and they have finally got to this point and understood something like, okay, so this 32 bits combination, binary bits. So binary numbers are nothing but zeros and ones. So binary 0 and binary 1. So with base 2 means totally there are two numbers. Two numbers, right? Okay, all right. So using the combination of these 32 bits, IPv4 is designed and they understood somewhere like this might not be sufficient for the future. So they have implemented IPv6 for the future purpose. Now, when they implemented it was future purpose, but now if you can see, IPv6 is already being used even in most parts of the world, right? Before it was only in the testing stage. So some major countries or some major companies implemented IPv6, but now it is expanded across the world. The world is experiencing IPv6 now. Okay, all right. So now we will understand about IP address. Okay, so how to provide or how to write an IP address will be seen. So let's write about IP address. So how to write IP address? So let me go with IPv4 first. So I'll go with IPv4. So as I told you, it is designed using the combination of 32 bits. So 32 bits, what do you mean by this 32 bits? Zeros and ones combination and up to 32. So if it is a 32 number, it is going to be very difficult for us. So what these 32 bits are derived as, separated as 4 bytes, means 8 bits equals to 1 byte in binary language. 8 bits is equals to 1 byte. So 32 bits, 32 by 8, it is equals to 4. So 4 bytes. So they have assigned something like, why can't we arrange this into 4 blocks? Instead of 4 bytes, I can call it as 4 blocks. 4 blocks. And these 4 blocks have 8 bits each. So it's very simple thing. Now you can see I got 8, 8, 8, and 8. So I got 4 blocks here. So four blocks of uh, bits, four blocks of address with 8 bits each. So this is how they provided. And to represent the IP address, so they have provided a dot between each and every block. And the IP address looks something like this. So I'm referring something like this: A dot B dot C dot D. IP address looks something like this: A dot B dot C dot D. Okay, but we don't know what are the values for A, B, C, D. Okay, so to understand the values of A, B, C, D, we are going to understand the range of IP address. It means if it is in decimal format or if it is in binary format, what would be the range? Okay, so I am writing range. So whenever you are telling about range, so what is the range? We can say very simple thing: least value to highest value. Okay, so basically, if you're going for a shop, right, and you'll go to the shopkeeper and you'll ask something like, okay, I would like to buy a pair of shoes. He'll ask you, so what is the budget you're looking for, or what is the range you're looking for? So you'll say something like, I'm looking somewhere in between uh, 1,000 to 2,000 rupees. So that would be your range, right? That would be your shoes buying range. That's it. So it's similarly here also the same thing. We got the binary numbers. So we should find out what is the range. Something like I told you, 2,000 to 2,000 is my budget, something for today. Similarly, range. Similarly, the range of IP address. So here we'll see binary numbers are nothing but zeros and ones. So to understand it, range is least value, which is nothing but all zeros. 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. This is the least value. And what would be the highest value? So because we got only two numbers, so we'll write something like this: 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is the least value and this is the highest value. But for a human, but for us, it is very difficult to understand this binary language. Okay, so we will take some time to convert these binary numbers to decimal numbers. So for our understanding, IANA themselves had made these changes and they provided us in terms of decimal language, but the PC will understand in terms of binary language. Okay, so so to make sure to understand about this binary language, so we will take a random number and we will take a small example. Okay, so I'm taking a random number and I'm showing you how to convert a binary number to decimal number. Okay, so when there are 8 binary numbers, so how you're going to convert them to decimal? Okay, now let us see it. We are going to convert something like binary to decimal. To binary to decimal. So I'd like to convert a number from binary to decimal. So here I'll take a number. So let me take a number something like it's 1 0 0 1 1 1 0 0. So this is my 8-digit number, which has to be converted to decimal. Okay. People who already know about these conversions are very good, but if there are someone who doesn't know about this basic level of things, for them this will be definitely useful. If you already know, that is well and good, but just in case if you don't know, then please utilize this. Okay, all right. So now I need to convert this binary number to decimal number. So to do this process, we require two. We require a base value. So binary has a base value of two. Now you might ask me, what is this base value? So this base value refers to the number of numbers inside this binary value. So inside binary, we got two numbers. One is 0 and the other one is 1. So it became 2. Okay. So using that 2 as your base, we are going to convert these binary numbers to decimal numbers. So you might ask me how you're going to do. Okay, very simple thing. I am mentioning 2 at every point here. So this is 2, again 2, I gave 2 here for almost all numbers. So it is to be multiplied and added with 2 power, with 2 power. So it is, this is 2 power. So firstly, I'll start from right. So that is the last number. So we have to start from last number to the first number. So it's 2 power 0 and 2 power 1 and 2 power 2, and 2 power 3. Okay. So it becomes 2 power 4, 2 power 5 and 2 power 6 and 7. 2 power 5 and this is 2 power 6 and 2 power 7. Okay. So this is how it is derived. Now we'll take for the mathematical way, which is, so I'll write here something like this. So now we have to multiply this. So first I'll multiply this. So multiply each number with each number. Something like this. Multiply them and add them. So you have to do this procedure first. And then you have to add both of them. So I'll just take a symbol, something like this here. Addition, adding them. Okay, firstly we have to multiply and then we have to add them. So this would be very easy for you to derive or understand the IP addressing in decimal form. So it looks something like this. So it is 1 into power. For power, I'm using this cap symbol, 2 power 7. 1 into 2 power 7. And again, I'll add it, sorry, add it. Then the other number here is 0. So 0 into 2 power 6. Plus, again, same logic. 0 into 2 power 5. Plus, you can see the other number. So what is the other number here? That is 1 into 2 power 4. So this is 1 into 2 power 4. Again, plus this is 1 into 2 power 3. Plus again 1 into 2 power 2. Plus 1 into 2 power 2 is done. So it is 1 into 0 into 2 power 1. And finally, we are coming to 0 into 2 power 0. I guess I had some mistake here. So we are good now. So we'll just see, did we clearly wrote it? So 0 into, sorry, 1 into 2 power 7, 0 into 2 power 6, 0 into 2 power 5, 1 into 2 power 4, 1 into 2 power 3, 1 into 2 power 2, and 0 into 2 power 1, 0 into 2 power 0. So everything is perfect. Now we are going to calculate them. Okay. So what is the value of 2 power 7? So let's come from the right side. So what is the value of 2 power 0? So what is the value of 2 power 0? Right, very simple. 2 power 0, anything to the power of 0 is equals to 1. Anything to the power of 0 equals to 1. So this is what mathematics we have studied earlier. But as of now, we will just remember this particular part. That is, anything to the power of 0 is equals to 1. So 2 power 0 is equals to 1. 2 power 1 is nothing but 2. 2 power 2 is 2 into 2. 2 multiplied by 2, which is 4. And 2 power 3, 2 into 2 into 2. That is 2 into 2, 4, and 4 to the 8. So 2 power 4, 8 to 16. 2 power 5, 16 to 32. 2 power 6, 32 to 64. And 2 power 7, 64 to 128. Okay. Now you can see this is, there are two up to 2 power 27, which starts with 128. The very first one, 2 power 7 is 128. So 1 into 128, it is 128 plus 0 into anything is 0. Again, plus 0 into anything is 0. Plus 1 into 2 power 4. So 2 power 4 is 16. Plus again 1 into 2 power 3, 8. Plus 4. 0 into anything is 0. Again, last, even at the last, 0 into anything is 0. Now, what is the total number here? So 128 plus 16. 128 plus 16 is somewhere around 144. So 144 plus 8, 152. 152 plus 4, it is equals to 156. So this is how we are going to convert a binary number to decimal number. So finally, we got an output here. So if it is written something like this, 100111100, this is a binary number and it has turned into decimal number called 156. I hope everyone are clear with this example. And if you understood the example, please drop a message in the chat box. If you understood the example, please drop a message in the chat box. Or if you have any questions here, you can raise your hand. All right, thank you. Any questions? Okay. All right. So now that I got the answers, thank you so much for that. Now let us find out the values of IPv4. So we have seen all zeros and all ones. So all zeros will be least value, all ones will be the highest value, and all the numbers in between these least and highest values would be the valid IP address ranges. Valid IP address ranges. Okay, now we have seen this particular example. Similarly, using the same process, if I am finding the value of this IPv4, so the range would be something like this. So this would become 0.0.0.0 because 0 into anything is again 0. This is very simple. But the highest value is not the same. Because if it is all ones, we had to add all these two powers. So it is somehow somewhere like it is. So 2 power 7 is 128 plus 2 power 6 is 64 plus 32 plus 16 plus 8 plus 4 plus 2. plus 2 power 0 is last one is 1. So this is the total combination. If you're doing the calculation, 128 plus 64, which is 192. 192 plus 34, which is 224. 224 plus 16, that is 240. 248, 252, 254, and finally it is 255. And some of you who's already into this uh, particular networking part or might have experienced something about IP address. So they might have seen this number called as 255, 255. So 255 is the highest value. Okay. So and now that has become the range here. So the address is something like 255.255.255.255. So the range of IP address here, the range of IP address is the range is 0 to 255. Okay, so 0 to 255. But there are some conditions. But there are some conditions. So what are those conditions? Biggest condition here is we cannot start an IP address with 0. So 0 will become as null address. 0 will become as null address. So I am writing here. It is very simple thing. So 0 dot 0 dot 0 dot 0. This will become null address. Okay. You might ask me, what is this null address? It means it doesn't have any value. So it indicates or it represents entire IP addresses, all the IP addresses which from 0 to 255. So it is going to represent entire range. Okay. So it is global communication address. We can write something like this. Okay. All right. So if we are excluding 0, so what is the valid range? So the valid range starts from, I'm discussing about only the very first range. Okay. So valid range. So for valid range, I am writing something like this is 1 to 255. Okay. But you have to remember, this is especially for first portion. So four blocks are divided into 4 octets. So this is only for first octet, or let us understand first block. Okay, only at the first block we have to use 1 instead of 0. It means from 1 to 255 instead of 0. We are excluding 0 only at the first block, and rest of all the blocks 0 to 55 can be used. Right? Okay. So here we have to remember this. Now, how to write an IP address? How to write an IP address? Now that we got to know the values, we will take a small example and we will write the IP address and find out whether they if the, sorry whether two pieces understand their language. Okay. All right. So firstly, I'll take again two pieces and we'll understand the communication. So this is my PC1 and this is my PC2. And I want these two machines to be communicated. Okay. So for communicating two of these pieces, we require mandatory what we require? We require a language and identity. Language and identity. So PC1 wants to communicate with PC2. Okay. So yes, there is a language called IP in between them. Now we are going to provide some set of IP address. So as I said, it starts from 1. So let's take it as 1. So I am providing 1.0.0.0 to this particular first PC. And I'll provide the same address on the second side. Okay, I'll write another address. So 1.0.0.1. Okay, because in every octet we can provide numbers from 0 to 255. So here I gave a small example. This is 1.0.0.1. Now my question is something like, will they both communicate with each other? Will they both communicate with each other? Okay. The answer is no. Please remember these points. The answer is no. They will not communicate with each other. You might ask me, what is the reason? The reason is pretty simple. Okay. Here, here, 1.0.0.0 is not an address, is not an address, because this is a very first number. This is the very first number in one series. So it is represented as ID. It is not an address. So it cannot be assigned to device. It is not an address and cannot be assigned to a PC, as it is used for a representation of a network, and it is called as network ID. Okay, you have to understand this point. So 1.0.0.0 is not an address. Okay, now you might say, what about 1.0.0.1? Yes, it is an address. So our next example is 1.0.0.1. So 1.0.0.1. And on the other side, I'll take again the same address, 1.0.0.1. Now will they communicate? Will they communicate now? So will they communicate? The answer is again no. They don't communicate. Why they don't communicate? Okay, for a funny example, just assume that your mobile number and your girlfriend's mobile number, if both are same, just assume both are same, what happens? So firstly, whether my question is it possible? Is it possible that two people and two mobile phones having the same number? It is not possible. It is not possible. Of course, two persons might have the same name. Name might be repeated, but number, if it is repeated, then there is no identity. And basically, when you're writing some examinations, you'll get some uh, entrance number or hall ticket number. So all these are referred as numbers because they don't match with others. But here, both PCs have the same number. So it is not possible. They're not going to connect because here it is called as IP conflict. IP conflict. Okay, right? So both PCs cannot have same IPs. Okay, all right. So this condition is also failed. Now what we'll do, we'll go with another condition. We'll write another number. So let me take another number as 1.0.0.1. And on the other side, I'll take another network as well. So 2.0.0.1. So will they communicate now? Do they communicate? Okay. Will they communicate? Again, the answer would be no. Because, because the IP address or the computer binary language. So separated these numbers. So this is represented as 1 and this is represented as 2. Now for this computer, for the binary language, these are two different languages. These are two different languages. Or exact word is these are two different networks. Both are not same. Okay, these are two different networks. So one is the very first one on the left side is called as 1 series and the other one is 2 series. one series and we can see two series. All right. So both are in different networks. And yes, our CCNA is entire thing about understanding working between different networks. If you remember yesterday's session, the last definition is about a router. A router is an internetworking device which is used to connect two or more different networks. It means by default, different networks are not going to get connected. So here we are connecting these two different networks in CCNA. So basically they don't connect because they are in different networks. Both are in different networks. So they don't communicate with each other. Okay. And finally, we'll see something called as 1.0.0.1 and the other one is 1.0.0.2. Now will they communicate? Will they communicate? Finally, yes, they communicate. Yes, now they will communicate with each other. Okay, right. So this is, I'm simply saying, this is successful communication. Okay, now this is the way how we are going to write the IP address. So if you want to create communication between two devices, you should make sure that two devices should be in same network. It means both PCs should get IP address from the same network. Okay, here one is common and the other one is, okay, the very first octet is common and all the octets are changed. Okay, then it is represented as same network, same network. So whenever you are writing this IP address, so we require two portions. We require two portions. So I'll mention it here now. So I am writing something like, so IP address representation is referred as constants, constants and variables. Okay, so IP address representation is referred as constants and variables. Okay, all right. So now these constants and variables. So you can see constants are the ones which which do not change. So constants basically represents the networks and they do not change. And variables so represents the host. Host means the end device. Host and they must be changed for every. Okay, or else they should be different. They should be different for every host. Okay, so this is our point for IP address. So let me save this and I'll share this to you. So this is batch 265. Okay, so I hope you understood about this particular point. Okay, so IP address is represented in this way. Okay, now that we have completed a basic topic, if you have any doubts, so please let me know. And meanwhile, I'd like to add our Okay, if you understood the topic, please drop yes in the chat box, or if you have any doubts, please raise your hand so that I can provide you access to speak. Right. Thank you, Pradeep. Thank you, Manoj. Thank you, Srinivas. So I am adding the WhatsApp channel here. You can click on the link and you can join to the group. Okay. Any questions from anyone? A quick questions? Any quick questions? Any quick questions? Anyone would you like to speak? Then you can raise your hand. Okay, Pradeep, I'm providing access to you. You can speak now. You can unmute yourself and you can speak.
Yeah, just wondering, like, when are you going to start actual sessions? These are, presume like these are demo sessions, right? So.
Yeah.
are-
So you have something like 4 demo sessions for you. These 2 demo sessions will be uploaded in YouTube, and tomorrow and the next session will be done continuously, 4 demos. And after 4 demos, who all are enrolled for the course registration process is done, then they will be continued from the next day itself. Day 5 would be your actual class.
Oh, okay.
Okay, any other questions, Pradeep?
That's it, like, I just want one, because I'm taking another class that actually runs from 7:30 to the prior to this class, so just want to figuring it out, like, okay, you stick to just 1 hour, or like sometimes it might go beyond 1 hour, so.
Okay, I got your point. I got your point. Okay, and Pradeep, just you can meanwhile, as you are on or you're on mic, so you can introduce yourself to us.
What did you say? I didn't get it.
Okay, as you're on mic, you can introduce yourself to us. Like something like what is your qualification or what?
Oh, okay. Okay. I'm Pradeep. Like, I'm already in IT, like I'm a database architect, so I'm taking this course more for my academic knowledge for networking side, because I always feel this is one area where I don't have complete grasp of it. So that is the reason, like, I'm taking this course.
Super. Fantastic, fantastic, and I wish you all the best.
Yeah.
Okay, thank you all. Anyone wants to speak now? If there is anyone else wants to speak, okay. If that is done, if no one has any questions, so then we're good to go. So that's all for today's session, team. Thank you so much. Again, we'll meet tomorrow at 7 a.m. IST. Thank you all. Have a nice day. One more question from Mr. Manoj. So Manoj, you can directly enter into our website and you can register over there. So you'll get our links, so you can do it. Yes, thank you so much.